Okay, so let's test your knowledge of fractions. And if you really understand fractions, then you'll be able to find the lowest common denominator of this problem very quickly. So what we have here is 1 over 25 plus 3 over 49 plus 7 over 125 plus 5 over 64 plus 1/7. Now, I'm not looking for you to add up all these fractions. All we want to do is find the lowest common denominator, and feel free to use a calculator. All right, so if you know how to do this problem, go ahead and put your answer into the comment section, and then by the time you finish with this video, you'll be an expert in finding the lowest common denominator. This is something that a lot of people think they understand better than they actually do. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades, and it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if you enjoyed this video, if it helps you out, make sure to hit that like and subscribe button, as that definitely helps me out. All right, so let's go ahead and get into this problem. And the whole idea here is this problem is pretty easy to figure out. In other words, finding the LCD if you really understand how to find the lowest common denominator, right? So in this particular problem, we have the denominators here, 25, 49, 125, 64, and 7. And you are going to want to find the LCD if we want to actually add these fractions up. So remember, when you're dealing with fractions, you can't add or subtract fractions unless you have the same denominator. In other words, if I had 3 over 7 plus 1/2, I can't add these fractions the way this is because they don't have a common denominator. Now, there's all sorts, as a matter of fact, there's an infinite amount of common denominators that these fractions have, but we don't want to use a super large common denominator. We always want to try to find the lowest common denominator, and that's what the whole kind of topic of this video is. And how do we do that? Well, let's go ahead and just take a look at some couple basic examples. All right, now many of you out there are saying, yeah, you know what, I'm pretty good with fractions. I know all about the LCD, so that's great. I want you to keep that confidence up, and let's take a look at two basic examples here. And let's suppose we wanted to add 1/3 plus 2/5. Well, here the denominators are not the same, so we would have to find the lowest common denominator. And most of you, I think, that have a general understanding of the LCD would say, well, the lowest common denominator here is 15. And in fact, you would be right. Now, what is the lowest common denominator? Well, the term here is pretty, self-explanatory. This is the lowest number that these two numbers in these denominators have in common. Okay, it's the lowest common multiple, but really, that's kind of math mumbo jumbo, and a lot of people still like, I don't really understand what that means as well. But a lot of ways people think about the LCD is the lowest number that both these numbers divide into without a remainder. So you're like, okay, well, 3 and 5, both of these numbers they go into 30. But that's not the lowest number. They also go into 15 without a remainder. So that's the lowest number. So that would be the LCD. And that's a pretty good way to think about the LCD. But that is not how we want to think of it in terms of how to find the LCD. But from a conceptual standpoint, that's pretty good. All right, let's take a look at this problem right here, 1/4 plus 3/10. So again, we have to kind of go through this mental exercise. Well, what's the lowest number both of these numbers go into? The denominators, right? So 4 and 10. So it's pretty obvious that they both go into 40. But is that the lowest number? No, your brain starts working. Well, no, they also go into 20. So the LCD for these fractions right here with these denominators is 20. Okay, so let's go ahead and start talking about how to find the LCD, because really that is the kind of my objective in this video. Okay, it's, of course I want you to be able to work fast, but you can work fast if you know what you're doing, right? Okay, so let's talk about how to find the LCD, and we'll use this basic problem right here, 1/4 plus 3/10. We already know that the LCD here is 20. All right, but what do we need to do to find the LCD? Well, we have to look at the respective denominators. In this case, we have 4 and 10, and what we want to do is prime factor each of these denominators. Now, of course, I can have more than 2 denominators. Like in our problem, I have a lot of different fractions, but let's just focus on these 2 simple numbers here, and let's take a look at the prime factors for each of these. Okay, so 4 and 10. Anytime you want to find the prime factors of a number, a great way to do that is using a factor tree. So 4, okay, you want to just start factoring this number. Well, the only way we can factor 4 is 1 times 4 or 2 times 2, and 2 is a prime number, so you would want to circle this, and 2 right here is another prime number. So 4 we can express as a product of prime factors. In this case, it's 2 times 2. But I want you to pay attention to what I'm going to say here, and that is anytime you have repeating factors like 2 times 2 or maybe 2 times 2 times 2, always express that as a power. So 2 times 2 is 2 squared. This is very important, and you'll see why in just 1 second. Okay, so 4 is equal to 2 squared. That's what those are the prime factors of 4 expressed as a power. Okay, how about 10? Well, 10 is 2 times 5. Those are the prime factors. 2 is prime and 5 is prime. We can't factor anymore, so we can express 10 as being equal to the product of 2 and 5. All right, so with all that being done, now we can find the LCD. So the LCD is basically a product of all the prime factors. We're going to take all the prime factors between all these denominators. Okay, we got this one here and this one over here. We're going to take all the unique prime factors and we're going to multiply them together, and that is going to get us to our LCD. So let's go and take a look at this specific example right here. Okay, so again, the LCD is going to be the product of each unique prime factor, but there's a little bit of a twist here, okay? And if you can remember this, then you'll be a certified professional expert in the area of finding the lowest common denominator. Okay, so here is our example. We have 4 is equal to 2 squared, and 10 is equal to 2 times 5. Now this 2 right here is the same thing as 2 to the first. So remember, the LCD is going to be the product of each unique prime factor. So let's just kind of scan our prime factors here. So here, this is a prime factor, this is another prime factor, and this is another prime factor. So here I have 2 squared, okay, so 2, we have a power of 2 as a prime factor, and this is 2 to the first. So here is the big twist, okay? If you have the same number to a different power, this is 2 squared, this is 2 to the first, all you need to take, okay, in terms of your having your prime factor in your LCD is the highest power, okay? So 2 squared, 2 to the first. We don't need to have this 2 to the first right here. We just need the highest power of 2, which is 2 to the second in our LCD, okay? So that represents a 2 as a prime factor. We always take the highest power of whatever powers we may have. So 2 to the first, 2 to the first here, 2 squared, we're going to take 2 squared. I'm sorry, I don't know if I said 2 to the first, because, you know, sometimes I forget. But anyways, there you go, 2 squared. 2 squared is going to be in our LCD. Now, what other prime factors do we have? Well, we only have one other, so we need 5 represented as well. Okay, so our LCD is going to be 2 squared times 5. 2 squared, again, is going to be what? That is 4, right? Times 5, which of course is 20. And that is how we get to the LCD. Okay, so the procedure, again, is we want to prime factor each of the respective denominators. Okay, we want to express those in powers. Okay, and then we want to represent, and of course, if we do have powers, we may not have powers. And then when you want to find the LCD, we just need to have each unique prime factor represented, and if we have repeating or the same base but different exponent, in other words 2 to the second or 2 to the third, we always take the highest power of whatever powers we have to represent that in our LCD. Okay, so hopefully you understand that, And if you're saying, oh, okay, I get that, then maybe you want to retry this problem. Okay, so let's apply our knowledge on how to find the LCD to actually solve this problem pretty quickly. Now, before we continue on, if you want to get better at math, you definitely can, but the key is to find a teacher that gives you clear and understandable instruction. So hopefully you like my teaching style, and if you do, if you're like, yes, I think I can learn from you, well, then you will love my full main math courses. So you can find the links to all of these courses in the description, but they include basic math, pre-algebra, algebra 1, geometry, algebra 2, pre-calculus, and a ton of specialized test prep math courses. Okay, so again, don't give up if you're having a tough time in math. I can definitely help you out. So you can check out the links to all these courses in the description. So let's get back to the video. And here is the problem again, right? So we're not going to add these up. We just need to find the LCD. So we're going to focus in on the denominators here. So we have 25, 49, 125, 64, and 7. Okay, you can see here I have all these numbers broken down, 25, 49, 125, 64, and 7. And what do we want to do? Well, we want to look at the prime factors of each of these numbers. And these are pretty common numbers in terms of, you should kind of recognize that we're dealing with things that can be represented as powers. Okay, so 25, for example, I think most people should know that, oh, that's 5 squared, right? So these are not overly difficult numbers. 49 is the same thing as 7 squared. 125 is the same thing as 5 cubed. Okay, so 5 times 5 is 25. 25 times 5 is 125. So now remember, because we want to prime factor, our denominators, and of course we want to represent any repeating factors as powers, we're kind of looking, hey, can I, easily prime factor these? And can I prime factor these numbers as powers? And you can see here, this is super easy because each one of these denominators can be represented with a prime factor to a particular power, right? So 5 to the second, 5 is prime, 7 is prime, so 7 squared is 49, 125, 5 cubed is, that's, of course, 5 is prime. Now 64, you might be saying, well, that's 8 squared. Well, 8 is not prime. So if you break down 64, for example, let me just do this real quick right here. So let's suppose, all right, 64, if you wanted to just do this as a prime factor tree, so this is going to be 8 times 8, for example. So 8 times 8 is not prime, so you keep going. So that's 2 times 2 times 2. That's 8. And then we got 2 times 2 times 2 over here. So 64 is going to be 2 to the, now 2 is prime now, right? 1, 2, 3, 4, 5, 6, 2 to the 6. So if you take 2, multiply by itself 6 times, you'll get back to 64. So remember, you always have to prime factor. Okay, so 64 is 2 to the 6, and then 7 is 7 to the first. All right, now this should be fairly easy to identify. So now we can just quickly build our LCD. Okay, so I'm scanning my numbers here, right? And I'm thinking to myself, all right, let's take a look at all the unique prime factors. I have 5s, okay? I have 2 7s, I have 2 5s, so I got 5 squared and 5 to the third. So I'm going to take the highest power of 5, right, into our LCD. Now let's take a look at 7. I have 7 squared and 7 to the first. I'm going to take the highest power of 7, so that's going to be 7 squared. So that takes care of the 7s, and that takes care of the 5s. Let's kind of cross these out. And that just leaves us with 2 to the 6, so we have to have that represented as well. Okay, so 5 cubed is going to be 5 times 5 times 5. That's 125. 7 squared is going to be 49. And 2 to the 6, we already saw that that is 64. So now this is where you're going to want to use your calculator and multiply these three numbers together, and you get 392,000, which is our LCD. Okay, so again, even if you took some time to have to, and you kind of struggle with this and played around with this and whatnot, but if you still got the right answer, that's very good. But I think that, if you really understand what you're doing, you're like, okay, let me see here. These denominators, I can express these pretty easily as powers of prime numbers. And because I know exactly how to find the LCD, I can quickly, at least get the products. Then, of course, I can get my calculator out and help me out, okay? All right, so even if you have a calculator and you're doing a fraction problem, you still need to know what you're doing. And by the way, this kind of procedure that I just went over in terms of finding the lowest common denominator, it's the same thing you have to apply when you're doing fraction problems in algebra. All right, so again, the whole idea here is to kind of remind you that, in basic math, there is a lot of things to master, okay? And one particular place that a lot of people think they know better than they actually do is fractions, but there's other stuff as well, like order of operations, decimals, place values, positive, negative numbers, etc. Now, if you want to review basic math, okay, I have a great little mini course. It's only a 3-chapter course, but it really will kind of revamp all your basic math skills. I'm going to leave a link to it in the description below. It's called my Math Foundations course, and it's a good review for those of you that want to kind of relearn math, and then from there you can move on to more exciting things like algebra. Also, I have a ton of additional videos on my YouTube channel that can help you out as well. Okay, so with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.